In a previous tutorial, you have been introduced to various performance metrics associated with binary classification using logistic regression. And in this tutorial, we will see how those metrics are computed in RapidMiner. In particular, we'll concentrate on accuracy, recall, precision, and lift. Now, you may remember that the heart of calculating all those performance metrics is what's called the confusion matrix. And the confusion matrix essentially documents the correct and incorrect classifications by the model. You have a binary classification setting. So there are two categories and the model classifies. Some it will classify correctly, some it will not. So the confusion matrix essentially documents the correct and the pattern of correct and incorrect classifications by the model. And then the various performance metrics are computed using the different components of that confusion matrix. I'll just show you one of them, remind you of one of them. One metric is sensitivity, also called recall, and that's true positives divided by true positives by plus false negatives. So essentially that's another way of saying what proportion of the actual positives did the model correctly identify. So there are other metrics like specificity, accuracy, and so forth. So let me quickly jump to, and by the way, I'll come back later on and discuss the lift performance metric in a little more detail. And so for now, let me jump quickly to RapidMiner and get started with it, showing you how these metrics are computed in RapidMiner. So here we are, and this is the same process model for identifying coronary heart disease patients. So I will not go on. This is the same model that was used in the previous two tutorials on logistic regression, so I won't repeat the model. All I will do is I will run it and then analyze the performance results from the model. Just to remind ourselves, the threshold that's been set in this run of the process is 0.5. That's the default threshold level used by RapidMiner. You can change that, of course. And also, before we actually look at the performance metrics, so let me click on the performance operator. And among the whole host of different performance metrics that we have in RapidMiner, I have identified just a few, the ones that I mentioned earlier. One is accuracy. The next one is precision, recall, lift, and also sensitivity. Let me see where it is, somewhere down here. Yeah, there's sensitivity, and the reason I wanted to show you that sensitivity and recall will yield the same result. So those are the performance metrics that I have identified. Let me run this process, and here is the confusion matrix that results from this model, from the training, and this is with the validation data after the model has been trained. So just remember, true equal to 1. So this 1 category means the individual actually has coronary heart disease. 0 means they don't. So to show you where these how these different metrics are computed in RapidMiner, you've seen the general formulas for that in the PowerPoint slides. I just want to show you how they are computed for this particular context, and hopefully that will clear up how these metrics are computed, and actually intuitively what they are telling you about the performance of the model. So I'm going to copy this confusion matrix into Excel. So bear with me a second here. So Control C. And by the way, just remember the overall accuracy was 85.32 because I'm not copying that value. And we'll have to remember that 85.32. So let me go over to Excel, and I will Control C, back to Excel, Control V. There we go. So there's the confusion matrix. So let's take each of those performance metrics in turn. First is accuracy. Accuracy is equal to Oh, let me write it first. The true positives plus true negatives divided by the population. I shouldn't say everything, it's a population. Okay, so numerically what that means is, so you can see out of all the true non-CHT patients, 926 were identified correctly. So one component of the numerator will be 926. And then out of all these CHT cases in the second column, 10 were identified correctly. Okay, so the other component of the numerator is 10, and of course the denominator is all those phone numbers added together. That's the population, so to speak, for this validation sample. 926 plus 157 plus 4 plus 10, and there's your 85.32%. So let me put that as a percentage. Oh, highlight that, put it as a percentage, 85.32, and a quick look at RapidMiner, there's your 85.32. That's how it was obtained. Okay, so now let's try and see where this class recall comes from, this 99.57%. So class recall, you have different recall metrics for each of those two categories. So recall for class 0, so there's non-CHT, this is class 0, non-CHT individuals. So recall means what proportion of the non-CHT people was the model actually able to identify correctly. Okay, so out of all these non-CHT people, the model was able to identify 926. So the likelihood, or rather the proportion of non-CHT individuals that the model was able to identify correctly was equal to 926 divided by all of the non-CHT people in the population. That's 926 plus 4. So the denominator is all the non-CHT persons. Out of those, 926 were actually identified as non-CHT, so that proportion is 99.5699, and put that as a percentage. There's your 99.57. So along the similar lines of same logic, what is this recall? Actually, recall is the same as sensitivity for category 1, namely the individuals who do have CHT, coronary heart disease. That's equal to the numerator would be, well, we know what the denominator will be. The denominator is all the people who have CHT in the population, which is 157 plus 10. And out of those, 10 were correctly identified as having CHT. So the numerator is 10 and the denominator is 10 plus 157. There you have your 5.9%. Let's convert this to a percentage. And there you have your 5.99%. So those are the sensitivity or recall calculations. Now let's look at precision. Precision is another way of saying how much junk are you bringing along with you. So if you think of a fishing net, you've designed a fishing net to catch a particular type of fish. So maybe it's doing a good job of catching that particular type of fish, but along the way it might be also trapping many other kinds of fish, and that's not quite desirable. So you want high precision. So let's see how we would go about computing that. So essentially it's saying how much of what you predicted is junk. That's essentially what it's saying. Okay, so I predicted, so for class 0, that's the non-CHT patients, I predicted 900, that means I means the model, predicted 926 were non-CHT. So the numerator is 926. Okay, and the total number that I predicted as non-CHT, as the model predicted as non-CHT, was 926 plus 157. So before I hit enter, look at the numerator and denominator. What proportion of what I predicted was junk, all right, or rather was good. So the So the denominator is 926 plus 157 and the numerator is 926. So 85.5% precise. So let me change that to a percentage, and there's your 85.5. So that's another way of saying 15% of what I identified was junk. Okay, so you want high precision, which means there's not a whole lot of bad stuff or junk in your net, so to speak. That's what the model is identifying. So let's look at the precision for category 1. So how much of that is junk? So we know the denominator will be 4 plus 10 because that's all the number I predicted to be in category 1, and the numerator will be 10. So that's 10 divided by 10 plus 4. Excuse me, there's your 71.43%. Let me change that to a percentage. There's your 71.43%. Okay, so there's your accuracy, recall, and precision calculation. So let's go back to RapidMiner and see the different performance metrics that we had. So I want to show you that recall and sensitivity are basically the same thing. So here's recall. So I just showed you where that 5.99% came about for category 1. Let's go back to Excel. There's your 5.99% for category 1. Coming back to RapidMiner, I'm going to change from recall to sensitivity, and notice that it will give you exactly the same number. So here's sensitivity for category 1 is again 5.99. So just two different names for the same thing. So I've shown you accuracy, precision, recall, and now I will focus on lift. Okay. So you can see this value is 469%. So let me just remind myself, I will just write this, that lift is 469% for category 1. These are individuals with CHT. So the lift is being calculated excuse me, for that particular category. I'll just remind myself, that's I write that number down. So coming back to the PowerPoint slide that we had, here's the formula for lift, but just informally, what is lift trying to compute? Lift, if you look at either the first or the second, either way we can look at it. The second formula may be an easier way to get introduced to this concept of lift. So it's essentially trying to tell you how well the model performs on the target group. In our case, this is individuals with CHT relative to how it performs on the population at large. Okay, so it's a ratio of 2 conditional probabilities. So the numerator is what is the likelihood that the model will classify an individual as being in the target group, in our case CHT, given that the individual is actually a CHT person. That's the numerator. And the second, the denominator is what's the likelihood that the model will classify an individual as CHT if that individual is randomly drawn from the population at large. Okay, so those are it's the ratio of those 2 quantities. And the formula that you see on top is basically just those 2 conditional probabilities expressed using the components of the confusion matrix. So let's try and keep this formula in mind, and I'll compute this for the RapidMiner output over here, and we'll try and reproduce this 469%. So let's get back to our Excel worksheet. So remember, the lift is the ratio of 2 conditional probabilities. The numerator is how good is this model doing given that the observation is from the target category. Our target category is persons with CHT. So we are really, when we say that's the target category, we are talking about this column over here. Okay. So as far as the model is concerned, there are a total of 167 persons in that category, and the model correctly identified 10 of them. So how well is the model doing? What is the conditional probability? This is the numerator. This is equal to 10 divided by 10 plus 157. That's how well the model is doing with that particular category. So given that the observation is from the CHT category, the likelihood that the model will identify it as being from that category is given by that number, is actually quite low, is 5.9%. Okay, but now let's look at the denominator. And the denominator is, if this individual is drawn from the population at large, what is the likelihood that the model will identify this individual as being from CHT? Okay, so this would be equal to, if you think of the population at large, we are thinking about this, all four categories in the confusion matrix, so that will be the denominator. But out of that entire population, how many did the model actually identify as being CHT? It's 4 plus 10. So the model identified 14 people, so that's the predicted one, 14 people out of this entire group as having CHT. So so the numerator is 4 plus 10. Out of the entire population would be 926 plus 157 plus 4 plus 10. Okay, so there we have it. So that's nice. Even worse is 1.2%. Okay, so now, so if we want to compute how much better the model is performing with the target group relative to some random person drawn from the population, you take the ratio of these two, this divided by this is 4.69. so let's do that, convert that to a percentage. Where is this percentage here? There's your 469.2. Let's see what RapidMiner had given us. There you are, 469.2. That's where the lift came from. So I hope you saw first of all how the lift is computed, and also what the interpretation of the lift is. Okay, it's trying to tell you how much better the model is at categorizing, at identifying cases that are from this one category, which in our case is CHT. And if you think about it, between CHT and non-CHT individuals, the purpose of building this model in this medical context is in fact to be able to identify CHT individuals well. Okay, so we would be interested in how much better than just doing things randomly would this model be capable of doing. So I've shown you in this little tutorial how RapidMiner computes these different metrics, performance metrics for binary classification, namely accuracy, precision, recall, and lift. And so I will end this particular tutorial here. In the next tutorial, what I'm going to show you is how one goes about creating a lift chart, which again is very useful for analyzing the performance of a binary classification model. And I'll show you first of all how to create a lift chart, and then how to interpret its output. So with that, let me stop this particular tutorial.